and then I'll post all the videos. So this is the 4th period video. We'll start at number 20, and we'll do every third one after that. So let's see. Limit as x approaches -1. First approach is always substitution and see if it works. It usually doesn't, but it might, so we got to test it first. So that would be 2 minus 3 plus 1. That's a 0 in the top. 1 plus 5 minus 6 is 0 in the bottom. So kind of as expected, it didn't work. But you always have to try it first. Now we have our algebra tricks. We'll hit all of them eventually, but the first one is factor and cancel. So 2x plus 1 and x plus 1. And then x minus 6 and x plus 1. So the x plus 1's cancel. And then we try again with our substitution. So -2 plus 1 is -1. -1 minus 6 is -7. So my answer is 1/7. That looks weird, but I'm hoping it's a substitution problem that works with substitution and I don't have to do anything with it. But we'll find out. Try substitution first. Tangent pi over 3 is √3. Cosine pi over 3 is 1/2. So that's √3 over 9/2, which would be 2 √3 over 9. And yeah, there was nothing tricky about that one. That was just plug it in. All right. 35 and 38. These are the ones that aren't hard. Just make sure you look at the correct graph. That's the big mistake that people make. So h of x, g of x. Red and pink's probably not the best combination of colors to use there. Okay, so as x approaches -2 from the right on the graph of h of x. So that's like a lot of things to keep in your brain all at once. Going to the graph of h, approaching -2 from the right. So -2 on the right hand side, that's approaching 4. And then I'll go to the graph of g of x. And again, I will approach -2 from the right. That's 3. And then 4 plus 6 is 10. Again, those aren't hard. It's just that people mess up when they look at the wrong graph. 38. G of 5. So no limits, just straight up look at the graph of g. G of 5 is that dot up there at 4. So 4 plus limit as x approaches 5 of h of x. So graph of h as x approaches 5. Oh, that doesn't work, because there's different sided limits there. So 4 plus doesn't work. You know what 4 plus d and e equals? D and e. I probably shouldn't even say equals, because it's not really equals. It just doesn't exist, is the final answer for that one. (41) Make a limit using both g and h and find your limit. Okay, so limit as x approaches. Let's pick a point that. Let's do 0. That'll be an easy one. Limit as x approaches 0 of g of x plus 3h of x. I pick 0 because there's nothing weird going on in 0. And so sometimes students get so good at the weird ones that when they want the limit as x approaches 0 of g of x, they like panic because they're like, oh, there's no dots, there's no jumps, there's no infinity. It's like, yeah, that's what makes it easy. The answer is just 1. And same thing for h. Limit as x approaches 0. There's no dots, there's no jumps, there's nothing crazy. It's just 2. So 1 plus 6 is 7. Let's pause for a brief moment here and let me remind you what the algebra tricks are. If you get 0 over 0, or infinity over infinity, I think I put my comment in the wrong spot, then ... you can factor and reduce. That's what we did on the first page. You can fraction and reduce. That's what we're about to do with number 43. And lastly, you can multiply by the conjugate and eventually reduce. But it always starts with substitution. You get 0 over 0, then you got to use one of our techniques. And usually, maybe even more than usually, maybe like always, you know which technique to use because it's not tricky. Uh-oh, I almost did not do the third one there. So we're going to skip 42 and 43 and do 44. Okay, I suppose we should verify that we get 0 over 0. 4 minus 4 is 0. And then 2/6 minus a third. Yeah, that's a third minus a third. So I'm headed to 0 over 0. So I've got to do one of the tricks on that one. So let's multiply by everything that'll make my denominators go away. So in the top, nothing really happens. We definitely do not want to distribute all of that stuff. We want to leave it factored because we're hoping something cancels. In the bottom, the first term, the x plus 2 cancels, and that leaves 2 times 3. And on the second term, the 3's cancel, and that leaves x plus 2. But let's be super careful that that minus sign goes to both the x and the 2. So 4 minus x, x plus 2, and 3. And then in the bottom, 6 minus x minus 2 would be 4 minus x. That's very convenient. 4 minus x's will go away. And then we get to try again with our limit. Limit as x approaches 4. 6 times 3 is 18. So we've seen a factor and reduce one. Now we saw a fraction and reduce one. Skip the next two. Oh, we're passing over the conjugate ones. Oh, I say that. 47 might be a conjugate one as well. So plug in pi. 1 plus cosine of pi over sine of pi. Cosine of pi is -1. Sine of pi is 0. So we get 0 over 0, which means we got to try something. So this one is a conjugate problem, but it's the trig conjugate problem. So 1 minus cosine squared in the top. Leave the bottom in hopes that something cancels. Sine squared plus cosine squared is 1. So what does 1 minus cosine squared equal? Sine squared. Again, that's where people mess up the signs on that, but if I move the cosine over, I get sine squared. So one of the signs will cancel. And let's try again with substitution. Sine of pi is 0. Cosine of pi is -1. So I just get 0. 0 is an okay answer. 0 over 0 was not an okay answer. All right, number 50. X goes to infinity. Okay, let's do it the real way, and then we'll do it the shortcut way. If x is getting really big, the only terms that matter are the biggest terms. So 4x cubed over -12x cubed. The x cubes cancel, and I get -1/3. Oh, the shortcut way is top no, bottom O, equal co. And this is an equal co problem. So we take those coefficients and we get -1/3. $53. Oh, one more thing on the shortcut thing. Again, only use it as x goes to infinity. Don't use it as x goes to 2 or 0 or pi. Like only when x goes to infinity. 53 is x goes to -infinity. I still want to be looking at the big terms. So 3x to the 5th over -12x cubed. That would be x squared over -4. And if I plug in -infinity, square it, I'll get positive infinity, but divide by negative, I'm back to a -infinity. So I don't know that top no, bottom O equal co works that great on this one. If the top no, which I guess means you know it's an infinity, but then you got to figure out which one it is. What in the world? Again, plug in first and hope that it works. E to the 2 minus 2 over natural log of 2. So that's e to the 0 over natural log of 2. But e to the 0 is 1. So, okay, yeah, that was maybe weird, but that was pretty easy because we didn't have to do any algebra tricks. Just plugged it in and it worked. $59. Which of the following is continuous at x equals 1? Okay, so potential hole here on this one. I can cross out the x minus 1s. If we plug in 1, we get -2. So there's a hole at -2, but the function's at 1, so that is not continuous. On statement 2, I got a left limit and a right limit going on, or I've got a left-hand piece and a right-hand piece. Half of 6 plus 1 is 4. Half of 6 plus 1. 5 minus 1 is 4. So those are equal, so that is continuous. So at the spot where there might have been a jump, it was sort of rigged so that there's not a jump. So one of them had a slope of 1/2, the other one had a slope of -1. So it's a jagged piece, but they rigged it so that it's continuous at x equals 1. And then lastly, the following is continuous. Well, the bottom's x plus 1, x minus 1. So whether something cancels in the top or not, it doesn't really matter. This thing is discontinuous at x equals -1 and x equals 1. I don't know if those are holes or vertical asymptotes yet. I'd have to factor the top and see, but I don't really care. It's not continuous, at x equals 1. So 2 is the only one that is continuous. That last one is kind of like 57 and 58. I don't care about holes or vertical asymptotes. I only care if it's continuous. Tanner?
I just get negative 2 on the first
Oh, that should be negative 1. Yep. Is that what you were? So when I plug in 1 to what's left, I get negative 1. But that's where the hole is. The dot is at 1, so those don't match up. Right, skip 60, skip 61, head to 62, another 3-part problem, which has a jump discontinuity. Oh, we saw this in yesterday. I can tell already that one of those does not have a jump discontinuity. F, G, or H. Do you know which one definitely does not have a jump discontinuity? Why not H? It might be a hole. Might not be, but it may be a hole. But definitely not a jump. So I don't even need to try that one. That's a no. Because it might be discontinuous, but it's only a hole. Alright, these others I'm going to have to check the left and right sides. At 4, so that's 16 minus 8 plus 3 is 11. And then half of 16 is 8 plus 4 minus 1. That's 11. So that does not have a jump discontinuity. That's 2 different parabolas meeting, but they meet at just the right spot. So one's steeper, one's a little wider, but they're attached there. So that only leaves G. Well, based on my answer choices, I guess it's probably G only, but we should make sure. 2 times 16 minus 3 times 4. 32 minus 12 is 20. And then 2 times 4 plus 16 is 24. So there's our jump. So G only. Alright, that concludes the 4th period video of every third answer. So make sure you press like and subscribe and mash the bell so you get notifications when my future videos come out. And comment below on which was your favorite problem.